Okay, so we're going to be looking at simultaneous equations today. So this kind of follows on from yesterday's lesson with solving equations. The key difference is now we've got two equations and we've got two things that we're trying to find. So a little bit trickier. Okay, so there's kind of three methods to solving them. I would recommend, if you're going to really practice one today, I would focus on substitution if you're not really sure. So that's the second one I'm going to go through. But I do think all are really useful. And there will be certain circumstances where it does specify what method you've got to do. Specifically, it may say doing it graphically rather than algebraically. So I would recommend having a look at all three. But we are only going to spend one lesson on this. So if you don't have time, just pick a method and go for that one. Okay, so we're going to start off by doing elimination, and this is a way of doing it algebraically. And a really key bit of advice would be, I would definitely number your two equations 1 and 2. So you can see we've put here a little 1 and a circle, little 2. That's just numbering them equation 1 and equation 2. Because what that allows you to do is to write next to it what you're doing on each step, so that when you come back to check it, you can see what you've done. Right, so it's called elimination, because what we're going to try and do is get rid of either x or y. So what we need to do is look at the coefficients of x and look at the coefficients of y. In this case, they're both 1. And what we're going to try and do is see, is there a way of subtracting or adding these equations to get rid of either x or y? So in this case, we can see that equation 1 and equation 2, the y coefficient of both is the same value. So in the top one it's 1, in the bottom one it's minus 1, but we can see they're the same size. So if we were to add these together, we'd have plus y and minus y. So what that would do, that would cancel out. So what we're going to do is we're going to write, step 1 is we're going to add equation 1 and equation 2. So we've got 2x and 3x. So we add them together, that gives us 5x. And we've got plus 1y and minus 1y. So when we add those together, we get plus 0y. So we can just cancel that, because that is plus y add minus y. So I'll put that out here so we know what we're doing. So we've cancelled out the y's now. And then to get what's on the right hand side, so we've added the two equations, so do 6 add 9, which is 15. So what we've got after doing our first step, we've got 5x equals 15. So the key thing being, we can see we don't have any y's now, we've just got x. So then if we divide both sides by 5, we just end up with x equals 3. So this would get you most of the marks, however we wouldn't quite get full marks yet because you also need to work out y. So in order to work out y, what we need to do is we need to go back to one of our starting equations, either 1 or 2. You can pick whichever one, you'll get the same answer either way. So let's pick equation 1. So we've got 2x plus y equals 6. And we know that x equals 3. So we can substitute that in. So we've got 2 times 3, which is 6, plus y equals 6. So taking 6 from both sides, that just tells us y equals 0. So our final solution to this is x equals 3, y equals 0. And it's really important that you get both of those solutions, because otherwise you won't get the full marks. You need to have x and y in order to get the full answer. Okay, so let's have a go at the second one. Let's see what we can do here. So again, we look at the coefficients of x and the coefficients of y. Again, this is 1 and 1. And we need to think, what can we do to these equations to eliminate either x or y? So because we've got a matching coefficient with the y's, we've got 1 for both. If we were to subtract, in fact let's do it the other way around, because 6 is bigger than 4. So let's subtract equation 1. So if we do equation 2, take away equation 1. So we're going to do 6x plus y equals 4. So that's equation 2. And we're going to subtract equation 1. So that is 4x plus y equals 6. So it's important to know, I did do it that way round. It doesn't actually matter, you'll get the same answer either way. So now we're doing a subtraction. So we do 6x take away 4x, which gives me 2x. We've got y take away y, so that's just 0. And then we've got 4 take away 6, which is minus 2. So we end up with 2x equals minus 2. So then dividing both sides by 2, we just end up with x equals minus 1. So we've got our x value. So to get our y, we then substitute that back in, let's say to equation 1, but it doesn't matter which, you'll be able to substitute into either. So we've got 4 lots of minus 1, so that is minus 4 plus y equals 6. So then adding 4 to both sides, we just end up with y equals 10. So our final solution is x equals minus 1, y equals 10. And a really good way to check these is check by substituting into the other equation to check that it still works. So we did this on equation 1. You could try substituting it into question 2 just to check, equation 2 to check that it works. So substitute x and y into equation 2 and check that it still makes the equation work. Okay, so if you want to pause the video and have a go, if you're feeling quite confident with it already, do have a go at these ones. So in particular the top one, this bottom one we'll have a look at how we do it in a second. Okay, so what we're going to do here is go through this first one in the way we did before. We can see now we're going to start off by comparing coefficients of x, coefficients of y, and we can see that the coefficients of y match again. And we can also see they're both positive sign, so we're going to need to subtract in order to do this. So we've got equation 1, equation 2. Let's do equation 1 take away equation 2. So we do 5x take away 2x, which gives me 3x. We've got 2y take away 2y, so that gives us 0. And we've got 13 take away 4, which is just 9. So 3x equals 9. So dividing both sides by 3, we end up with x equals 3. So we've got our x value, we just need the y value now. So we need to substitute back in to work out y. So let's use this first one. So we substitute in to equation, that's the second one, equation 2. So we substitute in, so we've got 2 lots of x, so that's 2 times 3 plus 2y equals 4. So 2 times 3 is 6 plus 2y equals 4. So taking away 6 from both sides, 2y equals minus 2, and dividing by 2, y equals minus 1. So we end up with x equals 3, y equals minus 1. Okay, let's have a go at this one. Slightly harder elimination question because we can see none of the coefficients match, so our x's and our y's don't match. So what we need to do is come up with a way to make them match. So what we need to do is let's try and get the y's to match. So we need to multiply equation 1 and equation 2 by something to make it so the coefficients match. So we need to times equation 1 by 2 and equation 2 by 3, and what that'll do is that'll make that the y coefficient is the same in both. So we're going to try and get the y coefficient of both to be 6. So the way you can think about it is you're trying to get them to be the lowest multiple of those numbers. So let's do 2 times equation 1, which gives us, so that's 4x plus 6y, so I've doubled both of them, equals 10, and I've got to double the other side as well. And on the bottom one we're going to be doing 3 times equation 2, so that'll be 15x minus 6y equals, and then we do 3 times minus 16, so minus 48. Okay, so you can see now our y coefficients 6 and 6, so it's now like the sort that we did before. So I'm going to relabel this one equation 2, in fact we'll do 3 and 4 for these with our new ones. So in order to get them to match, we're going to add them because we've got a plus 6 on this one on 3 and a minus 6 there, so we need to add 3, add 4. Okay, so we've got 4x plus 6y equals 10, and we've got 15x minus 6y equals minus 48. Okay, so adding them together, so we've got 19x, 6y's cancel, equals minus 38. So that tells me x equals minus 2. So I've divided both sides by 19. And then from there, just substitute into, let's say, equation 1. So I've got 2 lots of minus 2. So 2 lots of minus 2, so that's minus 4, plus 3y equals 5. So adding 4 to both sides gives us 3y equals 9. Dividing by 3 gives me y equals 3. So the final solution is x equals minus 2, y equals 3. And just one thing to note, at the start when I picked to make the y coefficients match, that was arbitrary. I could have also done it with x's, so I could have times equation 1 by 5 and equation 2 by 2, which would have then made the x coefficients both be 10, and I could have done it that way. So you can do it either way, and you'll get the same answer whichever way around you eliminate. Okay, so here's some practice questions to have a go at. So if you do want to have a go at these, in fact just ignore this bottom one, that's beyond what we need at the moment. So you don't need to be able to do the bottom one, so just ignore that. Okay, so the answers are, there we go. So if you're happy with them, we'll skip onward. So here is exercise 1, so this is the elimination one. So have a go at these using elimination. If you're pretty happy with this method, you don't need to do all of these, maybe just do one to check, and then skip over to the next part, which is substitution. Okay, so it says method number 3, this is the second one we're doing, solving by substitution. So what we're going to be doing this time is we're going to be rearranging one of the equations and then substituting it into the other. So like we did before, we're going to be naming our equations, equation 1 and equation 2. And then what we're going to be doing is rearranging. So here I've got 2x plus y equals 7. What we're going to try and do is rearrange it so it's got either x or y as the subject. So in this case, it'd be easy to get y as the subject, so let's do that. So in order to do that, we're going to subtract 2x from both sides. So we end up with y equals 7 minus 2x. So we've now got y as the subject, and we can now substitute that in to equation 1, because I've got y as the subject, I've got y here, so I can replace the y in this one with this y, which will then make equation 1 just in terms of x. So you'll see what I mean in a second. So if we've got 3x minus 2y equals 0, that is equation 1, I can then substitute in equation 2, which I've got here, wherever there's a y. So 3x, that stays the same, minus, and it's 2y, so it's 2 lots of 7 minus 2x. So I'm substituting in my value of y here, and that equals 0 from here. Okay, so then now I need to expand out the brackets. So I've got 3x minus, and then 14, plus, because I've got a minus and a minus, 4x equals 0. So then collecting the like terms, I've got 7x minus 14 equals 0. So then do a bit of algebra and we end up with x equals 2. Okay, so then similar to what we had before, we also need to work out y. So we can use our equation here. You can use either, but because this one's got y as the subject already, it makes sense to use that one. So if y is 7 minus 2x, I've got 7 minus, and it'd be 2 times 2. Because we know from here that x equals 2. So 7 minus 4 is 3. So our final solution is x equals 2, y equals 3 for that. So the key steps are rearrange to get either x or y to be the subject, and then from there substitute in and solve. But again, you do need to find out x and y to get the full marks. Okay, so I will go through these, but if you want to pause and have a go at them, that is great. What I would say is make sure you're picking a sensible one to make the subject. So in most cases, either x or y will be easier to get to be the subject. So for example, with equation 1 here, it'd be easier to get y to be the subject because it doesn't have a coefficient. So just a bit of advice there. Either way will work though. So whatever you prefer to do. You could also get x to be the subject, because that's on its own as well. Okay, so for this one on the left, I'll go through it now. I will be getting x to be the subject. So what I'm going to do is rearrange equation 2 to get x equals 5 minus 3y. And if you've done it the other way, don't worry, you may well get the same answer if you've done it correctly. So we've got x is 5 minus 3y. So what I'm going to do now is substitute that in to equation 1. So I've got 2x plus y equals 5. So substituting in x, I've got 2 lots of 5 minus 3y plus y equals 5. Expanding out the brackets, so I've got 10 minus 6y plus y equals 5. So 10 minus 5y equals 5. And then doing a quick bit of algebra, we end up with y equals 1. From there, we can solve for x using our equation here. So we've got x equals 5 minus 3y. So if y is 1, that tells us it's 5 minus 3, which is 2. So our solutions are x equals 2, y equals 3. And I'm not going to go through this next one, I'll just put the answers up. So bear with me. Okay, and here's the answer to the second one. I just noticed when I put the answers up then, with the one on the left, I'd done all the working out right and then just written out the very final answer wrong. So it's x equals 2, y equals 1 for that one, not x equals 2, y equals 3. I think I just made a quick mistake at the end there. Okay, here's exercise 2. These are all based on substitution, so have a go at these ones. With the graphical solutions, we won't have time to do that today because I'm already 17 minutes in. And it'll take a bit longer to explain, so we'll do that for tomorrow's topic, the graphical one. So we'll do algebraic simultaneous equations today and graphical tomorrow. So I'll also attach a couple of extension questions as well to the Firefly task, so if you do finish the ones on the slides, do have a look at them if you've still got some time left.